Hi and welcome to Build 2017. Today I'm really excited to bring you some work out of China around the Killigence team, building Killin for Apache. And I'm really pleased to have the founder and CTO of Killigent, Yang Li, with me, as well as one of my colleagues, Chi Zhao, who are going to talk us through what Killigence on HD Insight means and what the opportunities are. So guys, switching over to you.
Hey James. Hello everyone.
Hey guys.
Everyone.
Hey, this is Chi Zhao from US China. And with Yang.
Yeah, so hello everyone, this is Yang.
From Killing.
Yang,
He's a CTO of Killing.
Yes.
And in the past several months, we are really great to have a chance to work with Killing guys, come up with some great story and like to share with you today. Yeah, maybe we just directly kick off our sharing.
Okay, so let's start share the slides. Okay. Let's start with the today's big data analytics requirement. So when we talk about today, we definitely mean SQL on Hadoop. So there were days about NoSQL, but we all know that's just a compromise when the technology is not ready. And today we want a SQL, and we want it really fast. We're talking about sub-second query latency. There were maybe Hive or some other classic technology that gets you big query running, let's say tens of seconds or even minutes to hours. But we want instant, interactive user experience today. And thirdly, we do want that on cloud because we want to use the technology and forget about the DevOps. Just sort of flip the switch and start enjoying the business. And we want a elastic architecture, which means we can scale the whole thing, the technology, as we scale our business. That's the requirement.
So today you're going to show us how Killing can solve these these four fundamental requirements
exactly
on Hadoop for the big data interactive analysis.
Right. So
okay.
We're hoping to present to you that we have a solution for all the requirements you need. So talking about Apache Killing, so it was a top-level Apache open source project. The first one actually born in China. It was firstly incubated inside eBay and then open sourced to the world. It has been, I think, 4 years to now, so it's quite a mature product. It just got InfoWorld Award in 2016. In 2015, we hope we got it again this year. As you can see, we've got a lot of adoptions worldwide, but especially in China.
Seems maybe the top 15 internet companies already using that Killing, I think.
Exactly.
From the logos list here.
Exactly.
Okay.
We will say quite confidently today in China, all the internet companies, most 99% of them actually use the Killing.
Cool.
So quickly position up what is Apache Killing and where it stands in Hadoop stack. So it is I would say, OLAP engine that sits on top of your Hadoop and expose your data through a SQL interface to your online application, which is very different from, I would say, classic big data technology. So Killing allows you to query, for example, we have in total.com, 3 trillion of rows.
But that's a big lot of data.
It's very big data, and that's production. And with that amount of data, the query latency is under 1 second, which is very amazing.
This seems like unreasonable. Such big data in such a late latency, such a short latency.
Yes, exactly. So we'll talk about why, but the message here is that you can connect your online application to big data directly now.
Okay.
So a little bit of the technology behind. So what Killing does is what we call pre-calculation. So let's imagine a traditional aggregated analysis scenario. If you say, I want to understand how my return flag, my order states impact my revenue, you may write a SQL and the SQL will compile into a execution plan like you see on the left. So Basically, it means that you have to look at every row at least once to calculate the correct result. That gives you a open time flex to execute that query. And that will be slow as your data grows.
Right.
So what the pre-calculation does is that it picks out the most fancy operators here, table scan the join, the aggregator, and pre-calculate them into a summary table. Or in the jargon here, we call it cuboid, because killing is based on the classic cubing theory. But if that sounds unfamiliar, you can think as a summary table. So once you got a summary table, the scale of that table is only related to your business question. And in this case, it is only related to the cardinality of the return flag or the status and the date range you analyze. So that gives you a very, I would say, constant scale of data set. So when you execute the same query on the pre-calculated result again, the time complexity becomes O1. So that's the trick.
So that's a kind of long explanation, but in a nutshell, actually the killing does is using the space to exchange for the speed or for the time, right?
Exactly.
Okay.
So it's all about trade-offs. And people may ask, okay, I see one query get speed up. How about all kinds of flexible queries? So this gives us brings us to the pre-calculation space, classic cube. What you're looking at is what we call a cube. That is showing when you get 4 dimensions, you get all the possible different combinations of calculations that you can do. Well, that's 4 dimensions now. But imagine you got 10, 20, 100 dimensions. Space will go up exponentially. So that is a challenge that Killing solves for you. So Killing provides a model, cube, and all concepts that let you well-define the pre-calculation space such that it is affordable and it can answer all kinds of flexible queries in your business domain.
Okay.
So the idea, if you get the pre-calculation correct, you can get the speed for tomorrow. Right?
So even your data grows fast, but you can't really, your current speed kind of stay constant.
Exactly, that's the point.
Okay.
So once you get the pre-calculation model correct, no matter how big your data goes, your computation complexity is only related with your business model.
Okay.
So that gives you the idea when the data goes further, you'll get a very constant query response time. That's what Apache Killing gives you. Okay, so finally, the architecture of Apache Killing from a deployment point of view. So on the left side, we got the source. Apache Killing now can source from Hive, which is the most common big data in the Hadoop. And also it can consume from Kafka directly.
Oh, the streaming data.
Yes, exactly. Okay. We'll have a demo of it later.
Cool.
When the data came in, it goes to the build engine to do the pre-calculation according to the model and the cube you have defined. And the result of that will be stored in HBase. The cube is there. And when the query coming from the top, that's your BI tools, your web applications, your online SQL application, whatever, NC SQL goes to Killing, and the Killing goes to HBase to do the real execution and return you directly. So when the SQL query executes, it does not affect the source, the build engine anymore. It's a lightning fast.
Cool.
So we're talking about commercial today. So that's the commercial company behind the Killing.
So that's a nice comparison.
Yes, we hope we can be one of those one day. Nice. So Killing Genes is the commercial company that sits behind Apache Killing to support it, to grow the community, to provide commercial services. And we are on Azure now. That's why we're presenting here with you.
Yeah, that's the main reason why we're here.
Yes, exactly. So we have the commercial version of Apache Killing. We call it Killing Genes Analytics Platform. CAP, yeah. Okay. So basically it sits in the same position as Apache Killing, but it's now on the Azure, the HD Insight, and it can serve your data, big data in the cloud directly to your online applications, to your desktop BI tools, to your Excel, very lightning fast. Yeah. And with this setup, you get managed killing data analytics service. It's cost effective, pay as you go. It's elastic, can scale as your business scales. It's very secure. And we got the assistive modeling to help you figure out the right recalculation. So very quickly, a few steps if you want to provision a cap on your Azure. You have to get a HDI cluster first, of course. And then you got a custom ARM deployment.
So we already have an ARM template to deploy the cap onto the inside cloud.
Exactly. We'll have a live demo for that very quickly. And when you provision the application, when it's done, you got the cap running. On the fly quickly.
So I think we already got so many slides. Maybe we jump to the demo to see how it works.
Sure. We have 4 demos coming. Okay. Let's start with the first one that shows how to provision killing on HD Insight. So first of all, we are already on China Azure Marketplace. So if you are in China or your business in China, it's just a few clicks away. Oh, yeah, it's coming. Okay, sorry about the Chinese here.
Actually, it's already there.
Yeah, but it's on China Marketplace today, and we're working on the global Asia Marketplace. It will be in the global marketplace very soon.
Cool.
Like you see, if I get the template, ARM template, just create virtual machine, and you'll get a cluster provision and cap inside. That's simple. While if you're a global users at the moment want to try it very quickly, we also prepared you a shortcut for the ARM template we have just mentioned. So this is a page that's hosting in the Killing Machines GitHub repo. It's a little bit simple at the moment, but it will be gone very quickly once we got on the global marketplace. So right now, it's just 4 links if you want to deploy on your existing global Azure. Yeah, and also you can create a new cluster with cap. If you click this icon, it will bring you to the custom template form directly.
Maybe starting from here, we can take some coffee and wait for the customer to complete it.
Yeah, it usually takes 15 or 20 minutes to provision a cluster, but it's simple. You are drinking coffee.
Maybe we'll directly jump to some results you already created before.
Yeah, sure. So I'm just showing you just need to fill out the form and click purchase, and yeah, you're ready for your coffee. So I'm not provisioning a build cluster here, but I will show you something I've provisioned in advance. This is in China, Azure market, and I have HDI cluster provision in advance. It's a build demo, so I will use it to facilitate various demos coming. To show you the size of the cluster. It is a 11-node cluster, but chop off the head nodes, the super nodes, edge nodes. The real worker nodes are just 5 nodes, so it's from a capacity point of view, it's quite minimal. But we'll see that even given on this minimal configuration, it can also support very large scale of data. And in the application, we'll check cap is deployed. Yeah, there it is. And you got a few links about the user interfaces. I'll come back to it. Okay, so that's about the provisioning. So we've talked about the performance of Kitty and Cap, and we want to show it to confirm this in live. So what we are using is a star schema benchmark. I will quickly introduce what it is. So this is a step-by-step guide to guide you running the star schema benchmark on Killing. I'm not going through all of the steps, just the higher level ideas. The star schema benchmark is a serious benchmark. It is based on a paper research work, derived work of PCH, very famous benchmark in the OLTP domain. But we are talking about our AP today, Big Data Analytics. So the star schema benchmark is the tailored version of the TPCH. It is based on the star schema we are showing you right now. Based on a retail scenario, we got the transaction table in the middle. That's the service the fact table. And you got the customer table, supplier table. Part is a kind of item table. The dates play as the dimensional table surrounding the fact. So that's the basic setup of the benchmark.
The reason why they call it star schema because it looks like a kind of star, right?
Exactly.
The fact table is in the middle and the dimension table is surrounding the fact.
Right. Okay. So that's the kind of popular OLAP benchmark we have today. And it has a standard data generation tool. We'll skip the step of generating data because I've done it already in the Azure. We'll have to pre-calculate the data, which I also have done already. And we have a bunch of queries to run through. That's standard queries as part of the benchmark. So I will very quickly scroll through it. And that gives us to the result. So as we can see, with different scale of data, the SF stands for scale factor. We have a scale factor of 10, 20, or 40. Healing's performance is always the same. That confirms the O1 theory we have just introduced.
It's true.
It's true, yeah. In this particular benchmark, it's very true. Okay, so much for the theory. I will let you. I will get you take a look at its action. So I'm hitting the link to bring down the cap GUI.
So this GUI is from Killing.
Yeah. So this is the part of the Killing or the cap application. And we can quickly confirm it is loading SS data I just talked about.
Actually, how many data we are talking about?
Yeah, that's an interesting question. What you are seeing is actually a scale factor of 1,000. So that basically means the fact table has about 5 billion of rows.
A lot of figures.
Yeah, it's a lot of numbers. So it's 5 billion running on just the 5 worker node cluster. So with that amount of data, we can quickly see its query performance. So there is a query execution tool inside the GUI, of course. And I have some paired queries. So you can try with some of them.
So this is the standard SQL.
Yeah, it's standard SQL. Like I just shown, they're the code name, right?
Okay.
If I run this one, yeah, it gets you instant result at 0.12 seconds. And
that's so fast.
It's true. That's power of pre-calculation. I can try another query. Yeah, that's almost insane fast because I think that hits some patch. I can adjust some parameters.
Yeah, do some change.
Do some change to see how that works. Let's ensure it didn't.
We're not faking anything here.
Yeah, so let's say it's getting some filtering conditions of certain manufacturer. So let me change that, run it again.
Wow.
Yeah, it's still the same fast as you can see. So that's basically the benchmark is. And everyone can try that. We have the step-by-step guide up in public.
Okay.
Everyone who is interested can provision your own cluster and try.
So now on this cluster, we have 5 nodes do this query.
Yeah.
You just mentioned about the pre-calculation.
Yeah.
So for this kind of amount of data, we also do the pre-calculation on this fine node, or we need some more power to do the pre-calculation?
Yeah, that's a great question. Actually, pre-calculation is heavy, and we actually need a much bigger cluster to do that. So for instance, in this particular HDI instance, we have scaled it up to 25 nodes to do the pre-calculation. And when the calculation is done, we scale down it back to 5 nodes to keep the minimum. And that's the beauty of the something running on cloud.
Running on Azure.
Yes, running on Azure, exactly. Okay. Now we have seen some benchmark, and now I'll show you how the technology can interact with your desktop analytics.
The visualization part.
Yeah, the visualization part. Particularly, we can say, assuming I'm an analyst, I can sit on my desk and analyze the big data in the cloud super easy. So we'll show how Excel works and how it works. Okay. So this is Excel. So to load data from Excel to the cloud, we need a ODBC driver, which I have prepared here. Sorry about a little bit Chinese here, but it is I can translate for your ODBC data source manager. Right? So we have a data source configured against the Azure HDI instance I've just shown you, the build demo. So if I click up, you can see the server host build demo is connecting to the cluster we have just shown.
Same cluster.
The same cluster, yes, the 5 worker node cluster. So with this data source can load some data. Let's say, again, sorry for the Chinese, you will find the exact same feature in the English version.
Of course.
This is the data, this is a new query. And from other data source, you could choose load from ODBC. And here you give a chance to select source data. I will choose the Killing build demo, which is the ODB source I've just shown you. I have to tap query here to load the data. Let me pick up a query from the SSB benchmark. So let's see this one. This is a query about analyzing the internation transaction volume. So it is selecting the higher transactions between nations, and it's having a where condition. I'm going to remove because I want to load all the transaction data from the nation. And I also remove the audio by. And this pulls all the data between nations. I click enter to load the data. So what Excel would do is first give you a preview to let you confirm it is what you're looking for. I will confirm. I will do it will start to kick off the real data loading. And as you can see, it's not right. It's very interactive. Wow. So now you get the big data in your Excel, and you can do all kinds of fancy analytics based on which I'm not good at. So I will skip here. Wow. I believe there will be a lot of things you can do as real analytics.
The connection between Excel and the Killing or the inside cluster actually is already there.
Yeah, it's already done. So that's about Excel. I will switch to tab to give you some more insights about another kind of analytics, how can it go. So this is a desktop template, and it's connecting through the same ODBC configuration we have seen. And you can see we got the same data model. You can see here, we got customer, date, supplier, and the revenue, the cost, supplier cost as the measure. And for those you understand tabular, you know this is a prepared sheet that gives you the idea of revenue by location. This location here is a hierarchy. Highest level is region. We're seeing 5 regions, and I can
also drill down.
I can drill down, right? Let me try. Yeah, it's a drill down to states, to nations, and the drill down nation further to cities.
So each drill down actually you are submitting a query to the killing.
Yeah.
Okay.
So that's what Tableau different. So it has a online connection mode. With every interaction in Tableau, it actually translates the SQL to the cloud, and the killing can respond instantaneously and get you back to the.
So I think the integration between killing and the tablet is really great. But I'm not sure. Probably you already know that in Microsoft we also have a product named Power BI.
Yeah,
right?
exactly.
Do you have any plan to work out on the integration between killing and Power BI?
Definitely. Power BI works well with killing as in the same way Excel works.
Okay.
So
Cool.
it perfectly they can integrate seamlessly.
Cool.
Yeah. So, okay, that's for the BI interaction part. So this leads us to the final demo. So I'll show you how killing can zoom from Kafka and gives you a streaming assistant.
Cool.
So what I'm using here is a different killing instance, which has been running for months. It has been reading, sourcing from a Twitter example feed for a few months now. So let me first show you the killing instance. I need to go back to proxy. Sorry. Okay, what's the password? Yes. So this is open source killing instance. But what makes it interesting is that the data source of it, or that we select the project stream. The table of it are modeled from Twitter sample feed. So in this particular table, it's called tweets, but it has a streaming source. We can see the streaming cluster. It's Kafka. That's broken nodes. There are 3 of them. And the Kafka topic is Twitter sample. And every Twitter message coming will go through a parser, which converts it into a relational row record. And that forms the table we are seeing right now. That's it. Let me show you how fast it's building. So in the streaming mode, the incremental build is continuous. Actually, the incremental build is kicked off every 5 minutes. So let's see if you see this is 25 minutes build kickoff, and this is 20 minutes. This is a different queue. This is 30 minutes. So basically every 5 minutes, it sources data and we increment.
When some new tweet is coming,
exactly.
We do it.
Yeah. And with this setup, we can do very real-time analysis. So let me first check how many records we have. Tweets. Wow. So how much is that? It's 0.8 billion, right?
Right.
0.8 billion. And we can analyze the 0.8 billion rows in a new way. I'll show you. Killing also integrates with Zeppelin very well. If you're a data scientist, maybe you're more familiar with this tool. Open it up. It's also on the Azure HD Insight cluster we have just shown. That's the build demo cluster. And in this Zeppelin, we have a notebook prepared to analyze the streaming data I have just shown you. So Zeppelin is a kind of more geek tool. It allows you to write SQL directly. Write SQL directly inside what they call a notebook, and the result of that query will return back and help you to understand the insight of the data. So in this particular query, we're looking at every day and the daily volume of the Twitter. It goes up and goes down. and until today. And the next query is looking at the trend of the tweet feed from different kind of devices. We have two trends. One is Android, the other is from iPhone. And this time it is pinged by hour stuff. So every dot here is a hour update. And the next, we are looking at the minutes level, which give us insight into kind of language, tweets in different language, and how the trend up down in every minute. And finally, it's the tech cloud. What are the most popular tags you have right now? What people are talking about. So that's the keyword and their percentage, the total population of the land.
So all these kind of interaction analysis because the power of killing do the pre-calculation for the cube and that can empower this kind of code.
Exactly. So if I rerun all the reports again, with killing it will come lightning fast. Right. Just like I'm using a traditional relational database, every query I hit will come back almost instantaneously.
Very cool.
Yeah, so that's all the demos I have prepared. And with that, we hope you are kind of get more interested in the killing technology and especially on PhD side.
Right.
So it's just a few clicks away to provision a cluster in Azure to play with the killing technology. And well, I hope you enjoy the talk.
All right, fantastic. So thank you, Yang and Chizhao.
Thank you.
That's some really exciting stuff around high-scale BI and analytics, and I hope you find it useful. Thanks for viewing.
Yep.
Bye-bye.
Thank you.
Thank you,
Peace.
James.